Gonna do a little this. Gonna do a little bit of this. How's that gonna look? Bonjour and welcome to the basement of physics. We are still learning about levers. Today we are going to learn the very most important thing about how levers help us accomplish work. Let's take a look. Remember, the lever has three parts. Our fulcrum, the load, what we are trying to lift, and the effort, what we are lifting with. Now, when the length of the effort arm is equal to the length of the load arm, the effort and the load can be equal. We will take, I guess that's as simple as it comes. Now, if I have a lever with a much bigger load I'm trying to lift, this same amount of effort will not lift that big load. So the mechanical advantage of a lever is to make the effort arm twice as long. Now, the effort can lift twice as much. If I were to make the effort arm 3 times as long, this same effort force could lift an object 3 times as big. So, by extending the length of the arm, I can use the same force to lift bigger things, or I could use smaller forces to lift the same thing. That's what I will show you today. One classic lever is a hammer. Now, I can use a hammer as a third-class lever to nail in some nails. The length of the hammer makes it easier to bang them in than if I were to try to just hit them with a rock. Now, if I were to use a longer hammer, it would be even easier to bang them in. But I want to use these as a first-class lever to remove these nails. Now, if you recall from the last video, you will see that my effort is over here, the pivot is in the middle, and the load is on the outside here, and it will take some amount of force to remove that nail. If I extend the length of the effort arm, it will become, by let's say 2, it will become twice as easy to remove the nail. If I extend the length by 3, it should be 3 times as easy to remove the nail. Voila!